been toying around with this word energy for a little bit. I
Uh-huh.
was wondering if you could explain what that is, because
Yeah, it's
to someone who doesn't really study physics, it might be a very empty term.
yeah. So energy, I think, like at the high school level, we talk about it as the ability to do work.
Okay.
So if something has a lot of energy, you can channel that one way or another to do something, and that's kind of where the the story ends at like the high school level.
Which isn't very much, actually.
Which isn't very much. Yeah, and it's kind of, I think it lacks the exciting, like beautiful part of it, which is, it goes back to this theorem by Emmy Noether. Um, so when you write down this thing in this mathematical equation for some system called the action, and then I talked about symmetries of the action leading to conservation rules. The symmetry that leads to the energy conservation rule is a time invariance. So it's the fact, like the way it's popularly said is like, if you do a physics experiment now, or you do it in 5 minutes or in 2 hours, the physics is the same. The result is the same. And that necessarily means that there's some quantity that is conserved throughout the process. That quantity is what we call energy. So there's a deep like relation between time invariance and energy conservation.
Time invariance?
Yeah.
Okay.
As in like things don't change if you do them now or later or in the past.
In a physics standpoint.
Yeah, like I can drop this pen now and I can drop it later in the same position and the same thing will happen. In a kind of ideal world. Of course,
Yeah.
there are air currents and things that
Yeah,
like complicate this, but yeah.
Okay.